right, here we are learning with Mr. Neff. All right, we're going to solve linear systems of equations here, and we're going to pick our method. Really, they say three methods. Graphing is really not the one we're going to use. We're going to look at substitution, and we're going to look at elimination. Okay, so 4 examples here, and this will really help you. Writing these, it becomes more, once you've done a few times, it becomes a lot easier. All right, here a carpenter makes and sells rocking chairs. The material for each chair costs $22.50. The chairs sell for $75 each. If the carpenter spends $420 on advertising, how many chairs must he sell to break even? All right, for the first thing, we just need to define our variables first. That is the most important thing that we need to do. We need to define our variables. X is the number of chairs. Really, Y is money, whether it's spent or made. All right, we're going to look at it as money. That's what we see here. Okay, so 2 equations now. First one, Y equals 75X. That's what it's selling for. That's a revenue equation. So when we want to look at break-even point, we have revenue slash what we call income. And then we have a cost or expense equation, and that's 22X plus 420. And yes, that's a negative. It's an expense, but we're looking at as they go forward, where do they cross? All right, so we want to know what that solution is. All right, now, this is a substitution method. We know Y equals 75X, and we know Y equals 2250X plus 420. So we are going to set them equal and solve. Again, we get to this point, I'm not going to spend forever on how to solve. That's a whole nother lesson. You got to subtract 2250X and then divide, and you get X equals 8. He needs to sell 8 chairs to break even. Right? They don't even care about the money, although you can see the cost would be the same if you do the check. That's how you would do that. We only really cared about the X there. We didn't even care about the Y. We could find if we needed to. All right, first one. Okay, second one. Dylan is filling a 20-gallon tank and a 30-gallon tank for his fish display. The 20-gallon tank contains 4 gallons of water and is filled at a constant rate of 10 gallons per minute. 30-gallon tank contains 13 gallons and is filled at a rate of 7 gallons per minute. So X is your minutes and Y is your gallons. So we're going to look at what those equations are. First one is 10x plus 4, and the other is 7x plus 13 then. All right, and so we see that we're going to set them equal again. This is substitution method again. We're going to set it equal. 10x plus 4 equals 7x plus 13. Again, solving, this is assumed that you can do this, so x is 3. All right, now we plug this in, all right, and we get, all right, 34 then for the y. So we plug it into one of the equations, we get 34 for the y. Now you might be thinking about this. This doesn't make a lot of sense. All right, it says, I lost my screen. Let me see. Okay, but at 33 minutes, they will both have 34 gallons, but the tanks are not big enough, so there's no real solution. So technically, the solution to this problem is 334, but there's no real solution because the gallon, it only holds 30 gallons, and so that's kind of an interesting one. So we would say no real solution to that problem. All right. Next one, this one can confuse people at first, all right, but once you see it, and you want to refer back to this one, the speed of a kayaker is 5.75 miles per hour paddling with the current and 3.25 miles per hour paddling against it. What is the speed of the river current? All right, so if you can picture a kayaker, they are going with the current, all right, so you have a boat and then you have them paddling, and then you have the current speed. We don't know either of those. Those are our variables. So X is our paddling speed, we'll say, and Y is our current speed, the speed of the river that they're in. So when they're going with it, it's 5.75. So you have a with it equation, and then you have an against it equation, basically. So X plus Y is 5.75. X minus Y is 3.25. So take a moment and see if you understand that. That's the important thing to understand. And they're all done about the same way. Let's solve this. If you look, we have an elimination method type equation, because if we just add here, we're going to eliminate the y. So we don't want to do substitution here. We're going to do elimination now. So we're going to add the x's, get 2x, and we add the other number on the other side and get 9. And so x is 4.5. Plug it into either one of those. I did in the first one. Subtract 4.5 and you see 1.25. So they want to know the speed of the river current. So the current speed is 1.25 miles per hour. That's all we cared about was the y there as our solution. That's our third. One more. Okay, this one I pulled straight out of our current math book. And this one can really confuse people too as well. And doing it a few times, it gets much easier. Metal alloy is a metal made by blending two more types of metal. A jeweler has supplies of two metal alloys. One is 30% gold, the other is 10% gold. How much of each alloy should the jeweler combine to create 4 kilograms of an alloy containing 15% gold? Now, honestly, it might be beneficial to stop this video, reread that a few times before I even go over it, because there's a lot there. All right. Okay. So you have two alloys, mixtures together. Okay. And an alloy, mixing 30% gold, 10%, but they want to end up with 15% and 4 kilograms. All right. Then what's your key to success? Always. Yep. Define your variables. So X is the type 1 gold, 30% gold. So it's kilograms and 30% gold. Maybe it's going to be 2 and 2 here, guys. Maybe it's going to be 2 kilograms of 30% gold and 2 kilograms of 10% gold. Now, I'll let you know a little secret here. If that was true, that would be 20% gold. And so we know that wouldn't work. Okay. So we want an alloy mixture, all right, that will get us 15% gold. All right. So really, you would think you'd have more of the 10%, I believe, if I'm thinking about that right. So X plus Y is 4. It means both together, type 1 and type 2 together is 4 kilograms. But here, the next one is the tricky one, all right? So 30% of X plus 10% of Y has to equal 15% of the 4 kilograms. That is the tricky equation that most people can't do. So that's what you want to try and understand really well. 30% of X plus 10% of Y equals 15% of 4. And that's what the key to solving this correctly. Now, I would advise you as we solve this, to go through and multiply the second equation by 100, basically. That would make your life easier. So all I did right now is multiply the second equation by 100. And then take your pick. I decided to do elimination. I decided to take the top equation now. This is the very top equation. So I'm going up here to the top equation. I'm going to times that by negative 10, to get rid of this 10y. That's my goal here. So I'm going to go to the top by negative 10. When I do that now, I kind of flip-flop my height. So the second is right in the third row, and then the first is actually in the fourth. So it's a little weird how I did that, sorry. Atom, 20x will equal 20, so x is 1. So the 30% gold is 1 kilogram. Therefore, the 10% gold would be 3 kilograms. Okay, so that would be I don't think I even wrote the statement out here. It's 1 kilogram of 30% gold and then 3 kilograms of 10% gold will combine to get you 4 kilograms of gold at 15% gold. All right, that is the 4 examples. Again, review these a few times because watching them once might be a little confusing, but after you do it a few times, you can get really good at it. All right, thanks. That's all I have time for learning with Mr. Neff.